So this is the beginning of the dam project, my little hydroelectric power plant, which will generate a very, very tiny piece of electricity for me. Probably enough when I'm done to charge a cell phone, and not much else. And the first part of the project is to put a dam over this ditch. The ditch is fed by a spring far upstream, and it runs a lot of the year. Right now it's mostly dry. This is relatively dry. It's running at about 10 gallons a minute, which is not very much. And the height of my dam is going to be about 3 feet tall. I'm going to make it out of cinder blocks. And the very first thing I've got to do is mark the locations where I'm going to put rebar holes into the ditch, into the bedrock of the ditch. For that, I'm going to rent a rotary hammer drill, run it with a generator, and drill holes approximately in the center of where all the cinder blocks are going to be. I'm also going to put in a retaining wall at the edge of the ditch on each side, which will also have rebar drilled into it, mostly to protect the dam from erosion. When the water goes past, it'll be humming, and it will take out the side of the ditch very quickly if I don't protect it with the concrete blocks. The blocks will not be right up against the wall. I'm not going to dig it out. I'm going to fill in behind it and put a pool liner behind the concrete blocks, so it doesn't have to be a perfect water sealed dam. The pool liner will fix that, or the pond liner, if you will. So the next step in my plan is to drill holes in the bed of the ditch. It's down to the bedrock. I'm going to use a rotary hammer drill that I rented at Home Depot. $5 for the bit and $43 I think for the actual drill. And I have my own generator to run it, which I've done before. Should work pretty good. So the next step was to drill holes into the bed of the ditch with a rotary hammer drill, which I've done, and set rebar in, one rebar at least, into each block. I think if I was doing a taller dam, then I would consider one on each side of each block, basically double the rebar, but for a 3-foot wall I don't think it's necessary. It's probably overkill to do what I've done, but I wanted the dam well and truly anchored to the bed of the ditch. You might wonder what the garage door opener bar is doing in the creek. I'm simply using that as a straight edge. The next step is going to be building a frame for a footing. So I had to divert as much of the water as I could around the footing. I didn't entirely succeed, but it's getting a lot of it, probably most of it. And as you can see, that's all the water that's going to power the water wheel when it doesn't rain for a couple of weeks at a time. The footing is maybe close to halfway done. Tomorrow I'll finish it. So I've got the footing poured, one bucket at a time, a small bucket at that. A lot of manual labor to do this, but putting a cement mixer in the woods is just too much trouble, time, money. So I did it all by hand. It took me about a day and a half for everything. Rebar sunk in. I diverted as much water as I could from upstream with the pipe, but it's still going around some of it. And what's left, I've got siphons in a couple of places, which I hope we're going to keep up, because this needs to dry out overnight, set. By tomorrow I'll be able to set up a concrete block wall as my dam, and then fill in behind the sides of the dam with dirt and a pool liner, pond liner, to seal the whole thing up. So I've cut all of the rebar to the appropriate lengths for the wall. You may notice one of the pieces of rebar over there on the right is shorter than the others. It's because I'm going to make a gap in the wall where there will be a board across where my pipes are running the water to the water wheel at the top of the well. So I don't need it to go all the way to the top at that spot. I used a Ryobi battery-powered cutter to chop them all off. Very efficient out here in the woods. And not too expensive. If you do the same, make darn sure you're wearing your safety glasses and some hearing protection because the thing gets loud. Next step is to start putting blocks down, but first I have to reroute this water around the wall. So now I've rerouted the water from the little tiny dam upstream to go around where I'm laying the wall, and we'll have the room to put the wall in on all three sides. And I've got a little hose running again all the way around where I'm putting the wall to drain what's getting past the dam. Seems to be working pretty well. Next step is I gotta chainsaw some roots over to the side and make a little more clearance where the water's coming out so that I can get a bucket in there, which I can't do easily right now. So I've laid down the first row of blocks all the way around, retaining walls plus the dam itself. And the good news is that the footing is reasonably level. It's not perfect by a long shot, but the water under the blocks will fix some of that. And it doesn't have to be perfect anyway. So I've got the first row in filled with concrete. It took me way longer than I thought it would. And this is a lot harder than I thought it would be. So it looks like I'll be taking another day off tomorrow, on Monday, to finish this because the rain comes Wednesday. I'm pretty sure I can get the dirt in on Tuesday evening, but oh, this is so much more work than I thought it would be. Wanted to work on setting more rebar into the bed of the ditch to support the pipes coming down and going up from the dam. The ones going up from the dam will take in the water. They'll be perforated pipe. And the ones coming down from the dam will essentially serve to speed up the water a little bit before it hits the water wheel. It also serves to establish an exact position of where the water wheel needs to be. I finished beating in the downstream side of the posts. I'll cut them off at a shorter length later on, but right now I've got them all set up with their hose clamps and pieces going into the bank of the ditch. A couple, 3 feet on every one of them, so they go in a ways and they won't move laterally. And of course I've got the pipe set so that it's going downhill. I'm using schedule 40 pipe going from the dam down to the water wheel. because its weight is going to be carrying all the water, whereas upstream the light drain pipe will be actually in the water, so a lot of the weight of the water won't be pressing down on the pipe too much. It'll be pressing down on itself because it'll be completely inundated in the water. That's pipe 1 of 2. I'll put the second one in tomorrow, and then cut off the ends and make some risers for my water intake. And then this weekend I'll start working on filling in the edges of the ditch. So today is going to be my first leak test. I really don't expect it to hold water, even though there is 5 feet of dirt on either side. It's simply not possible to compact it well enough from the top, especially on the left side where it's an overhang, that the water just won't seep through it. And I couldn't buy clay to fill in the sides. I used topsoil, and then I compacted it as much as I could with a tree temper tamper from Home Depot, which worked pretty good. You cannot use just your feet. If you try, you'll find that when you use the tamper immediately after, it'll sink more because it's such a small spot that the tamper's doing versus your foot. I put caps over each side to direct the water into the center when it overflows. And as you can see at the bottom, I have essentially a drain pipe for maintenance. And it should allow me to just cap it and watch the water rise, which is what I'm about to do. First steps of making the powerhouse posts is determining their location. What I've decided to do is set up a square frame with my posts using a 6-foot 2x8. And what I'm doing is making my 2x8 as close to parallel as I can with the pipes. Naturally, I can't get too close to the edge of the bank, so I'm giving it a little bit of a hold, not much. Doesn't need one since all of the force of the post will be straight down, vertical, and any other forces will be offset by the 2x12s I plan to set in the sides and come back to 2 more posts farther back. I'm guessing right now that I'm going to cantilever this out about 5 feet on each side so that I can hang my water wheel, and have 7 feet coming back. All the posts will be concreted into the ground, and I'll put some nails in the ends of the posts so that they attach to the concrete real firmly. And the other ends of the posts will take up a lot of the water wheel offset simply by the lever motion, lever cantilever. Starting to build the powerhouse structure, and I have to have the beams cantilevered out so that the water wheel, which is roughly 2 feet wide with the cassettes and bike wheel axle sticking out, can be captured by the beams above. I am essentially putting the level, which is 2 feet wide, and roughly centering it over the top of the pipe so that the center of the level is about over the center of the pipes. That will tell me where to dig the holes for the other ends. These are 12-foot beams, and there's probably going to be about 4 feet, a little over 4 feet, cantilevered out over the ditch and above the ditch, which means that this nice 8-foot long lever at the other end will easily keep the whole structure from falling down. with the weight of the water wheel and a person potentially out here on a small deck where the bicycle and the powerhouse will reside. It's time to hang the water wheel from the steel parking posts, basically U-channels with holes in them. I started by hanging the water wheel about where I wanted it between the two beams using rope. The inner beam is still floating, meaning that I can move it from side to side. I haven't attached it at either end, so I can adjust it to wherever I want, up to the point that I've got everything fastened down below. This makes it a one-man operation, basically, which for an awful lot of what I do is by myself. What I'm going to do next is cut the posts off at the tops so that they're about even with where the beams are with a battery power sawzall, and that will allow me to get a lot more motion in the adjustment. I spun it manually just to verify that it does easily spin, and it does. Bicycle wheels make an excellent rotation mount. And the scissors arms allow me to easily adjust the position of the water wheel up, down, left, right, so I can find the optimal spot. Right now I've got it as low as I can, and I've got the outtakes maybe 4 inches short of the water wheel, which is fairly close. It's what I want. I think with a strong stream I may have to put a 45 elbow at the end of each one of those pipes and take them back just a slight bit so that when the water comes out it's pushing down on the water wheel instead of up. But most of the time water's going to have about that kind of outtake over there at the pipe. It's not going to be a lot of water, just enough to turn the wheel and not much more. I've spread out the swimming pool liner as best I can across the entire dam and down into the water. And what I'm going to do next is put a bunch of gravel over the top of it, not only to hold it down so it doesn't move, but to weight down the end where it meets the water as best I can to minimize water going underneath of it and to the sides, so that when the pond fills up with water, as much as possible, the only edges that the water will seek will be across the barrier at the back, which will be weighted down with gravel, and hopefully making as much contact as possible with the ditch surface beneath. Another adjustment, I put a piece at the end of each one of the 45s, and now the water at a weak stream is going right through the wheel's path, and it sped the water wheel up a fair amount. Not a lot, but enough. And now I'm wondering if I sprayed the whole water wheel with Rain-X, would it go faster because it would shed water faster? Right now, a lot of the water on the other side is spraying upwards, which I expect is a problem with all wheels. And if it was more resistant to water clinging to it, would it go faster, or would that be offset by the fact that the water on the other side is no longer clinging and therefore adding weight to the wheel and torque. Haven't decided if I'm going to do that experiment or not, because once I do it, it's hard to get the stuff off. The one to the left is the first extension that I tried to optimize the water going into the water wheel, and it was pushing the water pretty low, so I'm going to replace it with one that's at a longer angle and see if that helps put the water higher into the wheel. And it's working just a little bit better. You can see that the water is going into the veins slightly higher than it was before. And what you want to do is optimize torque. You want just as much torque as you can get. If anything, I'd like to put the pipe a little bit higher, but the pipe has to have a certain amount of drop or the water won't flow through it. The concept works great when there's plenty of water, but when there's very little water, not so much. The bike's going to have to go.